This is pre-AP pre-calculus. It's an introduction to rational functions. We're going to be identifying restricted values, the domain, x-intercepts, and the y-intercept. Consider the rational function f of x to find the indicated functional values. So before we do that, just a quick review of something that we should know right away. We should be able to tell what the y-intercept is going to be of this function. The y-intercept is going to come from dividing the constants on the top and the bottom. I believe we've talked about that before. So the y-intercept is going to be -3 over -6, which reduces to a half. So it's important to note, if we haven't noted this before, you can find the y-intercept by taking the constant in the numerator and dividing it by the constant in the denominator. Part A says rewrite the function in completely factored form. Since the numerator has a lead coefficient, its factoring is going to be a little complicated. It's a trinomial, 3 terms. We are going to split the middle term and factor by grouping. So this middle term of -5x, we are going to change this to 2 separate terms. To determine what those terms are, we need 2 things that multiply to get -2x squared times -3. Let's multiply to get -6x squared. And those same 2 terms to add to get the middle term of -5x. I think that you'll find those terms are -6x and +1x. These multiply to get -6x squared, and these add to get -5x. So this middle term gets split into a -6x and a +x, and the order of those terms do not matter. Now we have 4 terms, so if you factor by grouping, GCF of the first group is a 2x, leaving us with x minus 3. GCF of the second group is a 1, leaving us with x minus 3. You'll notice that in these 2 terms, this being one term, this being another, they both have the same factor of an x minus 3. So that GCF we can factor out to the front, leaving us with another binomial of 2x plus 1. So in completely factored form, the numerator of f of x is going to factor into a binomial x minus 3 and a binomial 2x plus 1. The denominator, x squared minus 6x minus 6, looking for 2 numbers that multiply to get -6 and add to get -1. Since the lead coefficient is 1, we can go right into the 2 binomials. I believe you'll find that that's x minus 3 and x plus 2. Here's where it gets interesting. So it's rewrite in completely factored form. So we just did that, and I'm just going to tell you something straight up right now that we're going to learn later, but we might as well just get nuts. Once again, to find the y-intercept, take the constants and divide those. Now from here, once we have it factored, we got all kinds of good information we can get from this. If a factor cancels from the top and the bottom, you're going to have a hole in the graph at whatever would make that factor equal to 0. So we're going to have a hole at x equals 3. If you have a non-canceling factor in the denominator, like the x plus 2, you're going to have a vertical asymptote at whatever makes that 0, x equals -2. If you have a non-canceling factor in the numerator, that is going to be how you find the x-intercepts, the zeros. To make this binomial equal to 0, x would have to be -1/2. This is what we're after in this chapter, being able to do that. I just basically told you what's going to happen. Let's continue. We were supposed to write it in completely factored form. We did that. I did a bunch of this extra stuff here in red, blue, and black. That's going to be relevant as we continue. I'm just telling it to you now so you can see it as many times as you can. This over here is all side work for me to be able to factor the numerator. What do you notice when you evaluate f of -2 and f of 3 in the factored equation? Well, if I put a 3 into this factored equation, I'm going to end up with 0 times something. I'm going to have 0 on the top as well. It's going to be undefined. If I put a -2 into this, it's going to be 0 on the bottom that we're multiplying by. It's going to also be undefined. Let's write that out formally. When the factors of the denominator are set to 0 and solved, the results are x equals -2 and x equals 3, which are the same x values that cause f of x to be undefined. Definition of a restricted value. The value of x is the definition of a restricted value. It's a value of x in which there is no y value. And a rational function, to remind you what rational means, it means something written as a ratio, that means a fraction. And a rational function, these are values that make any factor in the denominator equal to 0. And as we saw up here, there are 2 types of factors you can have in the denominator. Things that make wholes and things that make vertical asymptotes. If the factor cancels, it's a whole. If the denominator factor doesn't cancel, it's a vertical asymptote. The graph of the function we were just talking about is over here on the right. Describe the graph of f of x at its 2 restricted values. Well, you'll see at x equals -2, the graph is discontinuous. We would call that infinite discontinuity. And at 3, we can see it's also discontinuous. We would call that point discontinuity. As far as this question goes, we're just looking for at x equals -2 and x equals 3, the graph of f of x is discontinuous. What's the domain of the function? Well, the domain is going to be everything to the left of -2. That's that's negative infinity to -2. And then from -2 to 3, jumps over 3 and goes 3 to infinity. So that written formally is like this. To the back. From the equation of the rational function, how do you determine the restricted values? Well, you set the factors of the denominator equal to 0 and you solve them. From the equation of the rational function, how do you determine the domain? We'll just always assume the domain's all real numbers and then strip away the restricted values. From the equation of the rational function, how do you determine the zeros of the function? Well, the zeros are the non-canceling factors of the numerator that you set equal to 0 and solve. From the equation of the rational function, how do you determine the y-intercept? Well, the y-intercept is the ratio of the constant terms of the numerator and denominator. So notice it doesn't mention anything here about wholes or about vertical asymptotes. It's coming in the next section, but I think the more exposure we get to that, the earlier we get to that, the better for your brain. So I'm going to continue to do that. Rewrite each of the following functions in factored form. So if we split the middle term here, we multiply to get -18x squared and add to get -7x. If you did that, and then you split the middle term and factor by grouping, I won't get into all that right now because I'm pretty sure you know how to factor at this point. This would end up with 2 binomials, 3x plus 2 and an x minus 3. The denominator, if we factored it, we would end up with an x plus 1 and an x minus 3. The order in which you write the factors doesn't matter. Now, before we answer the rest of these questions, let's just write down a bunch of stuff that we know is true. We know that the y-intercept for this is going to be -6/3, which is 2. We know that since the x minus 3's cancel from the top and the bottom, there's going to be a hole in the graph at x equals 3. We know that since x plus 1 is a factor of the denominator and it doesn't factor, this graph is going to have a vertical asymptote at x equals -1. We know that since 3x plus 2 is a factor of the numerator, it's a non-canceling factor, this graph is going to have an x-intercept, a 0. Move this down a little bit so I can see, I can write this. We're going to have a 0 in this function, and whatever would make this binomial equal to 0, which is going to be when x is -2/3. We know all that just by the factored version of the function. All we were supposed to do is rewrite it in factored form. Identify the restricted values of the function. Well, the restricted values are what makes the denominator equal to 0. So x cannot be -1, and x cannot be +3. What's the domain? The domain is everything but these numbers. So the domain is going to go from -infinity to -1, and then from -1 to 3, and then from 3 to infinity. It's everything but -1 and 3. What are the zeros of the function? Well, once again, the zeros come from the non-factoring, from the non-canceling factor in the numerator. So the zeros of this are going to be at x equals -2/3. What's the y-intercept of this function? Would we divide the coefficients, the constants of the non-factored version of this? It's -6 over -3, which is going to be +2. If you want to write it as an ordered pair, you say 0, 2. Looking at this next one, we can say that the y-intercept, which I'm just going to write down here, that's going to be -10 over -4, which is 5 over 2. As an ordered pair, that's 0, 5 over 2. If we factor this, the numerator factors into an x plus 5 and another binomial of an x minus 2. The denominator factors into an x minus 2 and an x plus 2 because x squared minus 4 is the difference of two squares. Factors that cancel from the top and the bottom is x minus 2. That tells us this graph has a hole at x equals 2. Non-factoring, non-canceling factor in the denominator is x plus 2. Therefore, this graph has a vertical asymptote at x equals -2. Identify the restricted values of the function. Well, the restricted values, x can't be 2, and x can't be -2. It's better if I put the smaller thing on the left and the bigger thing on the right. Doesn't have to happen, but we can do that. And we write the domain, it makes it a little bit easier. Assume the domain is everything except for the restricted values. So it's -infinity to -2, and then -2 to +2, and then 2 to infinity. What are the zeros of the function? Well, the 0 comes from the non-canceling factor in the numerator. So the 0 here is going to be at x equals -5. And that is the gist. Please do the homework from the section, and hopefully that made some sense to you.